All right, so in the second part of this tutorial, what I would like to do with you is to walk you through a specific application of revenue management, but one that is actually very important, which is the notion of overbooking and cancellations. Not everybody that buys an airline ticket shows up at the time of departure of a particular flight. Airlines have to be careful about how they allocate their resources because they don't want to have empty seats at the end of the day. Let's say we have an airline that have 4 seats available, but we have 5 potential passengers that are trying to buy a ticket at this particular time. So if you knew that every passenger that buys a ticket shows up, then the optimal thing to do here would be to sell 4 tickets and to have 1 passenger that actually have to walk away without a seat. But on the other hand, if we know that some of these passengers that actually buy a ticket don't show up, then probably we would like to sell 5 tickets here, take into account the fact that maybe one of those passengers will not show up, and at the end of the day we're going to have a full flight and no empty seats. So this is the challenge, how you think about selling more than what you actually have in terms of capacity to account for the fact that there will be people not showing up. With the increase of revenue management system in this industry, what we see is that the yield on a particular flight has been going up. Essentially, this means that airlines are selling more and more seats and are filling up their flights at higher level of capacity, which is good. The downside of this is that part of this increase in yield is coming from the overbooking practices that they have been implementing. It's more probable today that a passenger that shows up at the airport will not have a seat available because the airline has been overbooking. The number of voluntary bumping, that number is going down. People are not willing to take this deal, but the number of involuntary bump has been going up. And this means customers that are not necessarily satisfied with the service because they have to stay. So being able to do overbooking is important, but being able to do overbooking carefully and efficiently is also very important. In order to think about overbooking, we need to introduce a model which is called the news vendor model. Let's think about this news vendor here that every morning has to decide how many newspapers to buy. Now the challenge of this news vendor is that demand is not fully known. So there's an uncertainty in the marketplace. So if he buys too many of these newspapers, what's going to happen is that there's going to be newspaper left over at the end of the day. And obviously a newspaper at the end of the day is not usable for the next day. So this is highly perishable inventory. If you don't sell your newspaper, you have to throw it away. Very expensive. On the other hand, if you're too conservative and you buy too few of this newspaper, what's going to happen is that there's going to be demand that is not satisfied. And obviously you're going to be losing the margin that you can make out of this product. So the news vendor every morning has to look ahead and think how many of this newspaper I should buy to meet my demand, balancing the risk of having too many newspaper left over at the end, which is expensive, and balancing the risk of having too few and having excess demand, which is also expensive. In order to do this, we need to introduce 2 key concepts. The first one is what is called the overage cost per unit. So this is essentially a measure of how expensive it is for the news vendor to have 1 excess unit of inventory at the end of the day. This can be just the difference between the cost and the salvage value. If there is a salvage value, it could be just the cost, or even can be the cost of buying that newspaper plus some purge cost if there is some additional cost that you need to pay to dispose that inventory that is left over. So this is the overage cost, and we measure this per unit of excess inventory. The other side of the coin here is the underage cost, which would be the case in which you don't have enough inventory to meet your demand. So it could be the margin, the difference between the selling price and the procurement cost, or could be that margin plus some sort of a goodwill cost if having a customer walking away has some future costs that you will need to take into account because of a customer is dissatisfied with the service you are providing. So in order to solve this news vendor problem, what we need to do is to first go and compute what is the overage cost and the underage cost, which is the cost of having 1 customer walking away without your product. What we need to do is to find a way to balance these 2 costs to find the optimal level of inventory. The fact that you don't know how many customers are coming is what makes this a difficult problem. So for that, we need to think about demand as some sort of a random variable, and this is an example of a demand distribution for that particular demand. Once we have this, what we need to do is to find a level of inventory, which is this quantity Q here in the picture, so that we can balance the expected overage cost and the expected underage cost. Well, the expected overage cost is the overage cost per customer per unit of inventory that is left over times the probability or the likelihood that your demand is below the inventory that you have. And what is your expected underage cost? Well, it's the underage cost itself, cost of having a customer walking away, times the probability or the likelihood that you see something like this happen, which is the probability that your demand exceeds the quantity that you procure. So balancing these two type of costs is essentially balancing or making the expected overage cost equal to the expected underage cost. When you solve for that equation, what you get is an expression that defines the optimal inventory level so that the probability that demand is less than Q has to be equal to the underage cost divided by the overage cost plus the underage cost. This ratio is known as the critical fractile, and so essentially to solve the news vendor problem, you need to solve this equation. Let's go back now to the overbooking problem and let's see how we can use the news vendor to think about overbooking. To be concrete, let's take an example. Let's take the example of flight 855 from Orlando to Washington. This is a flight that has a capacity of 132 seats. And let's say historically the company has measured a 10% no-shows. So this is the percentage of people that book and doesn't show up. So with this information, the company might actually go and authorize 145 seats to sell, so increase by 13 seats from the actual capacity. So this will be the overbooking policy. And let's say 145 seats are sold, but at the end of the day, only 120 people show up. If this will be the case, there will be 12 seats empty, and this is obviously a costly situation because you have those empty seats there, and let's say you're selling these tickets at $315 each. So this is how much you will be losing because of those empty seats. On the flip side, you might actually go and implement this same policy. You might actually overbook to a level of 145 seats as before, and then everybody shows up. If this is the case, you have 13 passengers that will be bumped, and this is also expensive. Let's say a bumping passenger will cost the company $15 because they have to pay for the hotels, and let's say $25 for meals. So per passenger, there will be a cost of $75 to bump a passenger. All right, so with this information, let's try to see how we can decide what is the best overbooking policy for flight 855. So what do we know? We know that they have a 10% no-show. So let's say there's a mean of 13 passengers that typically don't show up in this particular flight. Now, because we need to capture the uncertainty in the marketplace, let's assume that the demand for no-shows is a normal random variable with mean 13 passengers and with, say, standard deviation 5 passengers. So this is how many people don't show up, which is again some sort of a random variable. We know that the underage cost will be roughly $315, which is the price of that ticket, and the cost of overaging will be $75. So that would be the hotel plus the meal. We can go to our little formula and write that the probability that the number of people that will cancel is less than the quantity that we overbook has to be equal to underage over overage plus underage. So in this case, 315 divided by 390, which is 80%. So we need to solve this equation. This is known as the inversion problem for the news vendor formula. And we can use Excel. There's a formula in Excel which is called the norm-inv. So you essentially go and plug the fractile 80%, then you plug the mean of your demand, which is 13, you plug the standard deviation, which is 5, and this gives you a level of 17.2. Essentially, we run up to 18 seats. So what you would like to do here is to overbook 18 seats on that particular flight.